Welcome to a CCC Town Hall, Making Research Data Fair. I'm Christopher Keneally, host of CCC's Velocity of Content podcast series. Last week, the Spanish national government approved a strategy on promoting open science. Spain's Ministry of Science and Innovation said the effort would be implemented over a 4-year period, starting with a budget of 26 million US dollars for 2023. One objective is to promote the management of research data using the principles that data should be findable, accessible, interoperable, and reusable. Mandated by funders and governments and implemented at universities and research-intensive organizations worldwide, fair data principles, ensuring that data is findable, accessible, interoperable, and reusable, are expected to drive innovation in science in the years ahead. Proponents say FAIR will accelerate machine readability of research and thereby lift discovery to greater heights. Over the next hour, my CCC Town Hall panel will share best practices for developing research data that is fair through culture, training, and technology. We will learn how fair data saves lives, saves money, and drives confidence in science on 4 continents. And our very special guest, George Strawn, a scholar at the U.S. National Academy of Sciences, Engineering, and Medicine, who served as CIO with the National Science Foundation from 2003 to 2009, joins our roundtable discussion with reflections on a half-century of internet evolution and the transformative role of fair data in the future. Throughout the program, we will take your questions and comments via the LinkedIn Live chat. Let's get the conversation started. Barend Mons in the Netherlands, you are president of the Executive Committee of CODATA, the Committee on Data of the International Council of Science. As a molecular biologist, you are responsible for groundbreaking research on malaria parasites. In 2014, Barend, you became involved with creating the Fair Data Principles, and today you are a leading advocate for their adoption and for data stewardship, ensuring the quality of an organization's data assets. So why have you committed yourself to this ambitious effort?
Well, thank you for the question. It's actually enlightened self-interest in a way. If I look back a little bit, if I'm allowed, in 1996, when George was still very active in the internet, early internet, I started something called Scientists for Health and Research for Development, shared, because I saw that we needed a lot of better connections across languages in Africa. But then I really started to apply it for my own genetic research. And in 2005, I published Which Gene Did You Mean? Which contains my most hated statement, I think, why bury it first in narrative and then mine it again? And I was already starting to see the value of machine readable data, seeing that the amount of data we generate is so large nowadays, which is a lot later. We actually double our amount of information in genetics every 6 to 10 months. So there's no way to work without machines. And that's why I need fair data for my own research. But I also became an advocate because I think it can change the face of science and the whole way we do open science fundamentally, which is needed.
Christine Kirkpatrick, you lead the San Diego Supercomputer Center's Research Data Services Division, and you are head of GoFair US. Are data scientists the only ones in the research community who care about FAIR?
Definitely not. And a whole bunch of people are data scientists that wouldn't call themselves that. So data scientist is already a fraught term. But let me start by saying that I think that the answers to many of our societal problems, from climate to human health, you name it, are in data that we already have. And the answers are waiting to be unlocked. This is the reason that I have dedicated so much of my brain space and time to this. A 2016 Bloomberg survey said that 80% of the time that a data scientist spends with data is finding and cleaning data. And that wasn't the first time. Before they called it data science, in data mining, we had the same things in the academic literature, that people who had spent lots of time in school were spending time basically doing a lot of clerical tasks trying to clean up data. And so this is why I spend so much time trying to figure out the connection between the FAIR principles and time to science, making sure that data scientists or anyone working with data can get started quicker and spend more of their brain power on actual analysis. So I really think that anyone who analyzes data or relies on the data analysis, which again is anyone on the planet, should care about this topic.
And Eric Schultes with the Go Fair Foundation in Leiden, the Netherlands. What kind of data do we want to be fair? Are there priorities for certain types of data over others?
So sure, there's a broad spectrum of different kinds of data that we all care about. I think one thing that the FAIR Principles has done a very good job at, when you look at how these 15 one-liners, these FAIR Principles were constructed, it really elevates the idea of metadata to be a first-class citizen along with the data themselves. And so, I think one answer to your question, Chris, is metadata is sort of a non-negotiable for FAIR. Without FAIR metadata, that is machine actionable metadata, your data assets, no matter what they may be, will not be FAINR in any automated way. So metadata is a given. But then after that, we can say, there's certainly a lot of legacy data out there. We've already created huge amounts of digital information. We could say, well, yeah, all of that needs to be fair. But I think more strategically, we would say, well, maybe that data can be made fair at the time where it needs to be accessed again or reused. So that might be one way to kind of prioritize the verification of legacy data. And then looking forward, given that the doubling time for data may be as short as 6 months in some domains, there's an exponential increase in data. The verification in those domains, and let's say in high throughput data environments, could have a huge payoff, because even within a couple of years, you could have the majority of your data in that FAIR format already. So it's really a case-by-case basis. I think one should be very practical in the approach on that. But we have, I think, emerging strategies and guidelines for the prioritization on that.
Francisca Oladipo joining us from Abuja, Nigeria. Welcome. You are Professor of Computer Science and Vice Chancellor at Thomas Adewume University and founder of the Africa University Network. The effort to verify data across Africa was sparked by the COVID-19 pandemic and shaped by lessons learned from Ebola outbreaks. Tell us how those two dramatic healthcare calamities converge in Africa around research data.
Thank you, Chris, for having me. In the case of Ebola, the data collected from the countries that were affected in West Africa, East and Central Africa, they were taken away from Africa. They never returned. And so researchers from Africa and even from the affected countries and the health facilities no longer have access to those data. And even if we're able to find them, we're able to have access to them, they're not reusable, they're not interoperable. In the case of COVID, prior to the founding of our network in Africa, the data from Africa was poorly reported. But now with FAIR, our data has become global. We have a set of principles for researchers in Africa to share their data, for the data to be reusable, to be discoverable by man and machine. We're now able to generate, we're able to curate and hold data in residence. And of course, with FAIR, we've been able to establish data ownership in African countries. And many African countries are no longer anonymous in the sense that we can always tell where the data is, where it was collected, the address of the health facility, for example, or the research institution, and then, of course, where the repository is and how it can be found, the principle for the reusability, for the access, and everything around the principle of the management of the data. So our data now through FAIR are generally discoverable by both men and machines. Algorithms from researchers in China can actually discover data reposited in a small village in Nigeria or Uganda or Tanzania. Thank you.
And Deborah Drucker in Sao Paulo, Brazil, at Embrapa Digital Agriculture, one of the Brazilian Agricultural Research Corporation research centers, you hold a degree in forestry and work closely with GoFair's agriculture and biodiversity networks in Brazil. Welcome, and tell us, how will FAIR data help you advance the Embrapa mission?
So Embrapa mission, in short, is to provide knowledge to help sustainability of agriculture, and this is per se interdisciplinary challenge. And we do need data from different disciplines in agricultural sciences and environmental sciences. And very often we need long-term data to understand the complex processes that are also being affected by climate change, and all of that is needed to provide food, healthy food for everyone. So we do need data to be fair, and we have been working with that even before the concept was generated. So it's very important to have the data well organized and reusable with metadata and everything that the previous speakers already touched on. And it's also sometimes really time-consuming and expensive to collect data in certain places. So it's important to make the most use of it in benefit of society. Thank you.
Well, thank you, Deborah Drucker in Sao Paulo, Brazil. Obrigado. We will return to the roundtable with the audience questions for the panel later in today's program. You can use the chat function on the LinkedIn Live page and let us know what's on your mind. If you have a question specifically for one of the members of the panel, let us know who you would like it addressed to. Right now, I want to move around the virtual room and learn more about my guest's work on making research data fair. Bring back Barend Mons in the Netherlands. And Barend Mons, you devised the FAIR acronym. I guess you have a hand with acronyms. You have SHARE, and then you brought in FAIR. Explain what makes the 4 points of that compass, findable, accessible, interoperable, and reusable, so essential for research data.
Yeah, thank you. In fact, when we had the meeting and George was there, Eric, a few of us, we didn't even have the acronym in mind. We were just listing all the problems that we encountered with data and specifically making the machine actionable. That was the focus of the meeting. And there were all these kinds of principles coming up, and they were shuffled and reshuffled. And then at some point, I tried to synchronize them in the process, basically saying most of the data are not even findable, to be honest. They're hidden behind articles, supplementary data. If you're lucky, the link works. Machines still find that a nightmare, even if the article is open access, because, maybe on page 3, there is a link to supplementary data, and if you're lucky, it's PDF. So findability, and Christine already said, 80% is wasted of data science on finding data, making them interoperable, data munging. So findable is, of course, the first thing. If you don't find data, it all stops. Then, of course, when you find them, many of the data are not accessible. They're simply behind firewalls, or you don't know what the license is on them. There's no metadata, as Eric said. So in pharma, people won't use data, for example, unless they know what the license is. Am I allowed to use the data, and for what purpose? Then if you are accessing them, many times you spend a lot of time to understand them. They are not interoperable by nature, let alone for machines, even not for people. And of course, the final letter R, that's what it's all about. It's all about reusability. And even if they are findable, accessible, interoperable, and reusable, and interoperable, the reusability is also a matter of, are they fit for my purpose? It's not only like, oh, they're there, so I can reuse them. You need enough metadata to know how big the data are. You don't want to download a petabyte of data. What is the license on the data? Are they fit for my purpose? So as Eric said, metadata became more and more important during the first implementation years of FAIR. But when I was just reshuffling everything we came up with after the meeting, because the paper was only published in 2016 and the meeting was in 2014, this thing popped up to me because it was simply putting all the problems in synchrony and in order. And then I came up with the acronym, and I knew the moment it came up that it would be powerful acronym, of course, because you can hardly be against FAIR.
That's right.
It also has downsides. We can talk about that later. But okay.
Well, thank you, Byron. And in your work with the Go Fair Foundation, who have you persuaded to join the FAIR cause? Can you maybe drop a few names of researchers and public figures who have endorsed the FAIR principles?
Well, I remember George saying George was at the meeting, and he said, "Don't make it a new standard. And if you want this to be accepted very quickly, and even people that swim in the net and then want to wriggle out, it's too late." That was a very wise advice because, strangely enough, well, maybe in hindsight, not so strangely, the funders and the politicians were quicker to accept this idea than the researchers. So the EC, the European Commission, but also the Dutch funders, the G20, G7, it went very, very fast. And people started to require FAIR data because they were convinced that they were wasting their public research money and other money by supporting research that then yielded data that were at best usable and reusable for the people who generated them. But most of our data can be reusable for many years and by many other people. And that puts a much higher quality requirements on them. And then one of my frustrations has been, and I won't mention big names because I'm against the silverback culture anyway, the young people are adopting this much faster than the silverbacks. First of all, they are least affected by the problem. They are stuck to their Excel sheets and their fountain pens and so on. Don't even waste time. The next generation will take this very seriously. And I think it's much more telling that this month we will pass 10,000 citations on the paper. So it spreads over all disciplines in all regions of the world. We just heard a beautiful example from Africa. And we have a joke, though, internally, that at least half of the people that cite the paper clearly didn't read it because I don't think they really make their data fair. They just do some hand waving to satisfy the funders. So there's still a long way to go, but it is spreading all over the world very, very quickly now. We have reached the point.
And briefly, Byron Mons, I think you give us a sense that there's a real cost to science and to the public for not doing this job. But have you estimated the cost of verifying data? Can you tell us what that might be?
Well, not myself, but we all know probably that when the European Open Science Cloud was started, part of the exercise in the European Commission was to ask PricewaterhouseCoopers to do an estimate or a study on what is the cost of not having fair data. And I think they came up with pretty much an underestimation, but okay. They came up with about between 10 and 11 billion euros per year, only for publicly funded research in Europe. So I think if you multiply that by 4 for Europe, if you include industry and policy making, that is also needing a lot of data to be evidence-based, and then you do that again for the whole world, I think it's fair to say that we will lose about 100 billion at least per year. And we have even talked to pharmaceutical industries that said we alone lose 1 billion per year on bad data from all the companies that we have acquired. And then for 5% of the research costs that generates the data, we can make them fair and do proper data stewardship. That's a pretty good return on investment, I would say.
All right, well, Byron,
part the reproducibility crisis that is partly caused by non-reusable data.
Well, we will get back to that crisis and reproducibility later. But Byron Mons, thank you very much for giving us the background on the origins of FAIR. And I want to turn now to Christine Kirkpatrick with Go Fair US. And Christine, welcome again to our discussion. In your efforts to get the community, the science community, to adopt FAIR, does it come down to a question of making the FAIR data a matter of usability, user-friendly principles? And how do we do that? What can be done, do you think, to improve the process, improve the technology?
Well, first, let me say the FAIR principles are aspirational. So they're not It's not a specification, as Baran said. It's not necessarily tied to specific technology. So part of the work we do at GoFair International and GoFair US is to try and take those principles and translate them to practical actions and implementations. But at the moment, not enough is built into tools that are easy to use for researchers and people in industry. And so they're left to guess, and they're left to know a lot that's probably more technical than it should be. I've been in information technology for 30 years. And for those of us who've been on that journey, we remember early word processors. If you wanted to bold text, you had to know the function key. There was no way to look it up. There was no menu, and you had to memorize these things. Well, now we all use modern word processors, and you can just click something that looks like a bold symbol for B, and it's much easier. Same with electronic accessibility. It used to be pretty difficult to make PDFs, web pages, Word documents accessible for people with screen readers, for example. Most people had never heard of the W3C standards, the WCAG standards that help you do some of this. But now some of these tools are built into Word. You can right mouse click on a picture and it'll say, what's the alternative text? You put it in there, it's done to standards. Screen readers know how to make that accessible for people that are sight impaired. And so we're developing tools like this all throughout GoFair, but also the whole ecosystem. I myself have been working on a tool called Fairest, which helps people step through what they're doing with their data and tries to ask them in sort of a more TurboTax, for those of us in the US who know what that is, for filling out our taxes, something that's more user-focused. There's a whole bunch of other wonderful activities like that that are going to make it much easier.
And in January, Christine, the National Institute of Health issued a data management and sharing policy to promote the sharing of scientific data, something that was in development for many years. And moving forward, all data associated with NIH grant-supported research must be made publicly available in the NIH's own intramural database. And I understand you recently applied for an NIH grant. What did you think of the data-related questions in the application? Have they got it right?
Right. Well, it's one thing to be an evangelist and to talk about these things, and then it's another to put on your researcher hat and have to fill these things out. And I have to say, they're asking the right questions. I think it's going to be a game changer because instead of allowing people to opine, which all of us academics are good at doing, and sometimes it lets you dodge the specifics, it asks you, what formats and standards will your data be in? Where are you going to deposit your data? So again, I think it's a big step forward for anyone who's NIH funded. And many of those researchers are funded by different agencies. So they're going to bring those practices across to other places and lift the bar, as you will. And it's driving really important conversations across research teams. And those conversations are happening at the start of the project so that there's a chance for data to be born fair.
And those conversations you're talking about, I guess we're part of that conversation. And you have pointed out to me there's a project at the National Science Foundation, the Earth Cube, which is looking to create a kind of integrated data management infrastructure for geosciences. Briefly, would you say that a new data culture is emerging and being driven by FAIR?
Yes, well, and I know it's an often cited quote, but it's so true from Peter Drucker that culture eats strategy for breakfast. And so you do have to drive culture change. It was one of the honors of my career to be the PI of the Earth Cube Coordination Office, which closes at the end of this month as NSF finishes their 10-year project. That was an $85 million portfolio of projects to help Earth scientists and what we call cyber infrastructure providers, people like me, to work together. Two things I'll highlight. One is a flagship project called Decoder, which is built on something that was called geocodes. It gives you an interface to search across dozens and dozens of academic repositories that are focusing on Earth and the biological sciences now too. But the interface isn't even the important thing. It's working with the different repositories to adopt standards like schema.org and Science on Schema so that their data sets can be found not just by Decoder, but by the Google dataset search. The second one is that we really wanted to move the needle on reuse of data. And one of the ways that you can drive that is by the exchange of electronic notebooks, Jupyter notebooks that many of you might have used before. But we when we went to create a directory of these, we couldn't find them. And the ones we found, we weren't sure if they were good exemplars or not. So we created, along with the help of the founder of Jupyter, Fernando Perez, and other important technologists like Dan Katz at the National Center for Supercomputing Applications and Kenton McHenry, a competition, an annual competition. It's peer reviewed. Academics get credit for this. And they put up their notebooks. And now we have at earthcube.org a directory of geoscience notebooks. And so the more that we can put this into practice, have other types of scholarship, we're going to see data that's more fair and data that's more reusable.
Well, thank you, Christine Kirkpatrick with GoFair US. I want to turn now to Eric Schultes, also in the Netherlands with the GoFair Foundation. And we've just been hearing from Christine, Eric, about the advance and adoption in the US around this EarthCube project. But can you give us a reading on global levels of fair data awareness? And I'm fond of scales of 1 to 10. So in this case, well, 1 might be no signal detected, and 10 is been there, done that, got the grant to show for it. So where are we in adoption, in awareness, I should say, really even, of fair data?
Yeah, so I could try to, take my own experience and come down to a single number, but I don't think it would be that meaningful. What I can say, Chris, is that the landscape of fairness levels is very lumpy and very complicated. And there are vast plains of very low level fair awareness. And there are very high peaks in alpine regions where people are, doing work that I think, technologically speaking, could be around for a long time, because it's really cracking a lot of intellectual nuts. So it's a lumpy landscape. Baron mentioned earlier that the original FAIR paper that was peer reviewed and enunciated the FAIR principles will reach very shortly 10,000 citations. And one thing we'd like to do, I think in the next year, is begin to evaluate, kind of do a literature search on that to see exactly what are the disciplines and domains that are using FAIR and how they're trying to implement that for their own purposes. The other way of looking at this is that there's a lot of stakeholders out there. Baron also mentioned these high-level stakeholders like funding agencies and government ministries that were really the early adopters of this, or the early interested parties. And I think this is because, those groups feel the heat, right, when it comes to big budgets being spent on research. And then later on, there's a need for some kind of accountability. And, where's the data that was generated by that? So those high-level groups are very responsive to FAIR. And it turns out that the researchers, in my experience anyways, are often the least well-informed about FAIR. And in a way, that makes a lot of sense to me, because researchers are already highly trained and highly specialized in their particular area of research. To then go out and to begin thinking deeply about data and machine actionability, that's a whole nother, career path that we would really be asking a lot for researchers to respond to that. So, you mentioned, or you asked Christine some questions about the technology. I think some of the technological advancements that make FAIR more easy and more automatic, that's how you will pick up the awareness levels or the participation of researchers. But certainly from the high levels, there's a great deal of awareness and interest in implementing FAIR.
Well, something I need to ask you to help me understand, Eric, is about this notion of data getting lost, or even the danger of data disappearing, which sounds oxymoronical because there's so much data already and so much of it is produced every single day. So how can we keep producing more and more data and then losing it or seeing it disappear?
Yeah, sure. So, I think it's probably safe to say, I mentioned earlier that the doubling time for data could be, in some domains, as short as 6 months, right? So that means that of all the data we have today, 6 months from now, it's going to be doubled, right? A year from now, that's going to be quadrupled. So it's an enormous increase in data production. If that data is not made accessible online, let's say on the internet, and if there isn't sufficient metadata that can allow search engines or machine agents to locate it in some meaningful way, then indeed that data can be lost in plain sight, right? It'll be right under your nose, but you'll never see it. And the problem gets compounded every 6 months or every year, every doubling factor, because the rate of data creation is so enormous. And by the way, the data is complex as well. So there's lots of different domains, lots of different data types. So just for asking a human to manage the FAINR is just simply getting beyond human comprehension and human capability. So the machine has to help. Otherwise, in fact, the data will no longer be FAINR for anyone.
Well, Eric Schultes in the Netherlands, thank you so much with the Go Fair Foundation. I want to turn now to Francisca Oladipo, who is in Abuja, Nigeria at the Thomas Adewume University and the founder of the Africa University Network. And we were chatting earlier in preparation for our program, Francisca, and you were telling me about the effort to collect all of this data to make it fair. And you were contrasting the work you did in Nigeria and in Ethiopia. So tell us about the special challenges that you face in those two very disparate countries.
Thank you. For Ethiopia, it was kind of easier because there was more like a central authority that was prior to the conflict in Tigray. So we needed just approval or the buy-in from the Ministry of Health and then the universities. But in case of Nigeria, there are 36 states, and then there is the federal capital, making 37. So we had to convince 37 different entities with different laws. And then there are also different levels of health facilities and institutions. Some are owned by the states, some are owned by the federal government. So it was kind of easier in Ethiopia. And that was why we were able to move faster in Ethiopia than in Nigeria. Because even after getting a buy-in from a state authority, there is also the need to get a buy-in from a federal authority and then a primary authority. When we're talking about getting an ethical approval for the work, we had to go to different parts of the country and different ministries of health, for example, different institutions. Even though there is one body overseeing tertiary education in Nigeria, but each individual university has some level of autonomy. So that is one big challenge working in the two countries. Ethiopia was kind of straightforward prior to the conflict, but Nigeria was quite hectic because we had to replicate things. It was circular, it was repetitive, but that is the law and that is the way, the structure, the way the research community, the research approval in the country, that's the way it's set up.
Well, Francisca, you managed to make it work. So I want to hear your pitch, whether it was to those national governments or to the various state governments in Nigeria and so forth. What's the pitch? What do you have to say to convince them that sharing data, collecting data according to the FAIR principles is so important?
Already we had to remind them or to make them understand that they all know that the difficulty in collecting data. What they don't know about is that there is a principle that could make things easier. And then so we had to go African to remind them of the problem that we face, the problem of data collection. And then as a computer scientist, we had to use case studies. Our machine learning and AI models are trained with foreign data sets. Many data collected in by Nigerian researchers are not fair. They're not available, they're not findable, they're not accessible, they're not interoperable and reusable. So it creates a kind of repetitive process for the researchers. You see, an average PhD candidate in Europe will spend between 3 to 5 years. In Africa, if you're spending 8 years, nobody sees it as anything. But out of the 8 years being spent, the first 4 years or thereabouts will be dedicated to data collection. So we have to present those different kinds of case studies. And then in the health facilities and the ministries of health, there was a pandemic. And so we presented an opportunity for Nigeria to join other African countries in the fight against the COVID-19 pandemic. How? We cannot be at the forefront of vaccine detection. There's a lot of misinformation going on, so we cannot even really compete globally in trying to use the communication science to fight against the pandemic. There is a new kind of science. So we presented to them the new kind of science, the science of fair data that will assist the frontline healthcare workers with data for them to, do analytics, understand progression. And of course, we also brought up the idea of globalization, that now Nigerian data, African data can be discoverable outside of the shores of Africa. So we had to use different approaches. Actually, it depends on who we are talking to. We had to kind of look at the different circumstances. When it is the federal government, we look at globalization. When it is the state, we look at inclusion within a federal system. And then, of course, we had help. Globally, we had our partners in Europe, we had the funders. So all those big names also help. So when we hear, a group of Nigerian researchers are working with researchers are proposing to work with researchers in Uganda, in Kenya, in Tanzania, Nigeria is going to be part of a global thing. So those were some of the pitch topics or pitch areas that we use to ensure the buy-in. Then we had African students who are PhD, and they needed the African data pipeline. So through them, we're able to convince the heads of the institutions, the heads of the health facilities, and then the ministries of health to buy into the Vodan Africa and then Fair in Africa project.
Well, Francisca Oladipo in Abuja, Nigeria, thank you for that background. It is a very persuasive argument indeed. And I want to turn finally in our walk around the virtual room to Deborah Drucker in Sao Paulo. And Deborah, welcome back. And we were speaking earlier about Embrapa and the research that you are doing on a wide range of issues facing agriculture in the tropics. And an objective is to unite all the disciplines that are involved, which can range from soil conditions and plant diseases to sustainable farming methods and so on, under a single data tent. So tell us how far along you are in this quest to create that single data tent, and what role are you expecting FAIR data to play?
Yeah, so it's much more complex than it might sound. Actually, what we are so Embrapa Digital Agriculture, which is the research center I work for, is one of the 47 research centers in Embrapa, and we host Embrapa's data center. And we are a 50-year-old organization, so there is a lot of data that has been generated all over the years. And in the previous decades, many information systems were built, but then they became obsolete, and it's very hard to tailor a specific system for a specific project or discipline or subdiscipline. So we are hosting the institutional repository in order to sustain and preserve this data for a long term. And on that, we can build tools to really mobilize this data and analyze it and help really building solutions for the agriculture in the field. So we also host an API platform that reads the data and provides solutions and on-time predictions like on the productivity or related to climate hazards and things like that, as an example. So we have a huge, we have more than 8,000 employees, and it's a lot of work. So it's very hard to build a one-size-fits-all solution, but with the repository, it's already one step. there are many other initiatives. We are working on the data that it's legacy data to make it fair, and also for the new data and future projects, we have a new data policy that's very much based on the FAIR principles, and we have data management plans and things like that to deal with this really huge challenge. And we also connect with other institutions. We are connected with the GoFair office in Brazil, and we are engaging other organizations to mobilize the data producers, the data consumers, and well, it's a lot of work, but it's also fun.
Well, it sounds like it is a lot of work, and your situation kind of echoes the description that Francisco Oladipo gave us regarding Nigeria and the various states there and the states in Brazil. And you mentioned Embrapa is 50 years old. 50 years old this year, I believe. It's the anniversary. Half century of data, half century of research. Tell us a little bit more briefly about the data culture at Embrapa.
Yes, for sure. So in the beginning, you used to have a data quantitative department where the researchers would send their data in floppy disks for the analysis, and then with internet and everything, the different research centers and different groups have been building their own paths, and that will vary with the different challenges of the disciplines and everything. And it's more of what was already said. People don't like things that will, like if they need to write the metadata, that's something people don't like doing. So the most machines can do for us, the better. And there is also different approaches on sharing data. So in some cases we cannot share it because there are companies that are connected, or if there are some personal information involved. But we do need to make it fair anyway, and to host it and to preserve and describe and everything. So it is a challenge because it's different from most researchers, especially the ones that are here for 50 years are used to. But many also see the value, and it's good to know that the data is published, and if people will use it, people will cite you and things like that. So the culture is changing. But I can say that most people in Embrapa and elsewhere in science want to see science progressing. So it's a matter of communication and engagement. And I think it's still a long way, but people usually see the value. So it's good to see things evolving.
Well, Deborah Drucker with Embrapa in Sao Paulo, Brazil, thank you so much. And, the discussion so far has really sharpened the focus for me on why fair data is fundamental to the future of the internet as a welcoming place for innovation and discovery and research. And I think we can see paths for improvement, and we can begin to understand how fair data will lead to breakthrough interoperability across research domains. So we'll bring back the panel. We're going to have a discussion with you, but I first want to welcome a very special guest and continue the conversation with him. It's time to say greetings to George Strawn, a scholar at the U.S. National Academy of Sciences, Engineering, and Medicine. George Strawn served as CIO with the National Science Foundation from 2003 to 2009. And he joins us today in our roundtable discussion with reflections on a half century of internet evolution and the transformative role of fair data in the future. George Strawn, thank you so much for joining us today on the CCC Town Hall.
Glad to be here.
Now, you identify 3 steps in the evolution of computing. The first step came after World War II with the ENIAC and UNIVAC, the first programmable digital computers. They were enormous standalone machines. And then came the internetworking era that began in the 1970s when you were starting your own career as a computer scientist at the University of Iowa. What new era in computing will fair data bring?
Well, thank you, Chris. I think that's the right head in the clouds question. As you say, the first wonderful step was computers themselves. The second equally important step has been the internet age of interconnected computers. I think FAIR is ushering in the third phase of information technology, which is interoperable data as well as interconnected computers. And looking back over the past couple of decades, I think I can highlight three examples that already prove the value of this third phase of FAIR data. The Human Genome Project discovered eventually 20,000 genes or so of the human genome, and all of those gene discoveries were placed in one FAIR database. What if we had had 20,000 independent researchers, each contributing their own data in a non-compatible format, and then somebody had to try to put that data together afterwards? We didn't call it FAIR back then, but that's what it was. The Human Genome Database was a FAIR database that accelerated greatly the conclusion of the Human Genome Project. In a different discipline, although beginning about the same time, astronomers worked to get all telescopes to have standard output metadata, that is FAIR metadata, that in effect allowed all pictures of a given part of the sky to be overlaid, looking for similarities and differences and whatever. This resulted in astronomy being now called the virtual observatory. And according to my understanding, it has revolutionized the science of astronomy by being able to have FAIR from the instrument data. Third and most recent is the solving of the 50-year-old protein folding problem, which is an example of machine learning. And of course, we now know that machine learning is in the news as should we worry about futures? Well, perhaps we should, and perhaps that's a discussion for another day. But certainly the benefits are at least as large as the dangers. Byron has pointed out from time to time that FAIR is an overloaded acronym. It can also stand for fully AI-ready data. And in order for the training of machine learning algorithms to occur, the huger the better, databases of data needs to be analyzed to do the training to make the algorithms work. Well, that's what happened with the protein folding problem. People have been working for 50 years on finding a computing way to solve that problem rather than the expensive and time-consuming X-ray crystallography approach. A couple of years ago, it was designated as the science breakthrough of the year and is revolutionizing a proteomic part of biology. If we think of the revolution in proteomics, in genomics, and in astronomy, these three breakthroughs have happened because of FAIR data, even though we didn't call it FAIR at that time. I'm convinced there are untold additional breakthroughs of those magnitudes that will be available with the progress that my colleagues have just described as we are moving forward to fully implement this third phase of information technology, interoperable data.
Well, George Strawn, thank you for that. And thank you for adding to our definition of FAIR. I love fully AI ready. That seems perfect and brings us right up to date from the internet birth to today, because AI is so much on people's minds. We've had some questions about the study, the use of data in the training of things like ChatGPT, which are, of course, large language models. as you say, George, it's a topic for another town hall. In fact, we did a town hall on ChatGPT about a month ago. But I want to ask an open question to the panel here about the relationship of that other piece of AI that, George, you raised it, the concerns people have about AI, the power of AI, the potential for it being not all for the good. Does fair data play a role in developing greater trust in science? And Byron, and I see Christine nodding. I'll let you go first, Christine. So what about that? What about sort of fair as a way to help the public feel more confident in research and to trust the science that they're told about?
Absolutely. This is something that we're working on and that's very needed. Several of us on the panel are part of something called the Fair Digital Object Forum, which is working on what we think will be the next architecture of information for the internet. And if you remember back, those of us who were there when we had our first websites, you had no such thing as a secure connection. You didn't see a lock in your browser. There was no such thing as that. And then over time, we had certificate granting authorities, and people started to look and they said, I'm not going to put my credit card information in unless I see a lock up there on the top left in the browser. We're going to develop the same things, and we're going to need everyone to learn how to look for whatever the equivalent of the lock will be. But right now, there's a whole bunch of information coming out of AI that's just garbage. I also wanted to highlight another project. It's called FAR. It's Fair and Machine Learning, AI Reproducibility, and AI Readiness. And this is a consortium of people who are looking at the intersection of these two things. If that interests you, it's farr.rcn.org, and we'd love to get your thoughts, especially people who've tuned in and have more to say.
Well, thank you, Christine. And it's interesting, not surprising to find you involved in that.
Can I say something, Chris?
Absolutely.
Yeah.
Byron, please. Thank you.
Because I'm just back from a World Forum of Frontiers, the publisher, and we had a very good keynote of Yuval Noah Harari on the future of AI and of course, the dangers of ChatGPT type and large language models. And I actually have a whole schema worked out with a small group to offer to the large language model providers nano publications, which are fair digital objects, as Christine said, with full provenance, because it all comes down to trust. Which source do I trust? Who do I trust? As Christine already said. And these nano publications have complete provenance. Let me give you one example on the notorious thing that hydroxychloroquine would treat COVID. That was published in the Lancet. So, these language models will just pick it up and tell you it's a good idea. And if you are able to feed them with machine readable provenance information, they would find out that now about 500 orchids, people, scientists don't believe this anymore. And there's probably 2 people in the world that still believe it. We won't mention names. So the idea is really that if these large language models, which are potentially powerful, they're just word calculators, of course, they actually could be very important in the future if they cough up scientifically validated information, and they tell you if you only believe a subset of information, even a subset of scientists, in which bubble you are, so that you can also leave that bubble again and say, what if I look at this thing from a totally different perspective? And that is where FAIR will play an enormously important role in the future.
Right. Well, thank you. And Byron, you talk about provenance and the reliability. And I want to end our discussion. We have come through the hour. It's been fascinating. I want to end with Francisca, though, because you've been talking about the importance of including African-born data, I'll call it that, in the global data network. And when we speak about these large language models, questions are raised about whether they are diverse enough in the sources that they probe and whether they sort of reflect biases and so forth. So it sounds to me like you would be also part of really wanting to see fair data, verified data from Africa included in the training that happens for these LLMs. Is that true?
Yes, that's true. That's correct. It's actually part of the goal. We are looking at the globalization of data collected from Africa. And so, yes, it's part of the goal, and we are encouraging researchers who are working in the areas of LLM and those who are working in machine learning AI, who are working generally in a natural language processing, to ensure that they concentrate also on low resource languages, like languages that languages are spoken by millions, but there are very low resources for them, to ensure that at the end of their research, to ensure that not only the data, but all the research artifacts are verified, and then they're discoverable by these language models.
All right. Well, thank you, Francisca. And, British economist and Nobel laureate Ronald Coase once said that if you torture your data long enough, it will tell you anything. Today's CCC Town Hall has taught us the value in treating our data well, because then it will return the favor. I want to thank my guests, Barend Mons, president of the Executive Committee of CoData, the Committee on Data of the International Council of Science, and with the Go Fair Foundation in Leiden, the Netherlands. Thank you so much, Barend. Also, Christine Kirkpatrick, head of Go Fair US, based in San Diego. Eric Schultes with the Go Fair Foundation in Leiden as well. Francisca Oladipo joining us from Abuja, Nigeria, professor of computer science and vice chancellor at the Thomas Adewume University and founder of the Africa University Network. And Deborah Drucker at Embrapa Digital Agriculture, Sao Paulo. Thank you all very much indeed. Rob Simon of Burris Marketing is our director. Thanks as well to my CCC colleagues, Joanna Murphy-Scott, Amanda Ribeiro, Haley Sund, and Molly Taylor. Stay informed on the latest developments in publishing and research by subscribing to CCC's Velocity of Content blog and podcast. CCC's interactive visual report, The State of Scholarly Metadata 2023, is online at stateofmetadata.com. We invite you to have a look, interact with it, and share with us the problems and the challenges that you have around metadata. Again, that's at stateofmetadata.com. I'm Christopher Kenneally for CCC. Thanks for joining us. Goodbye for now.